There is no denying that sciences are a part of being an electrician. The challenge though is to present it in a video and make it fun. Here's a summary of some of the things I've learned this week in my journey in becoming an electrician. All of the sciences an electrician needs to learn is not rocket science. They're not solving the universe's unknowns with lengthy mathematical equations. But science is so important to electricians or trainee electricians. For a start, we have systems that require correct management in the event of faults and correct sizing for their purpose. All of these systems need calculations to correctly design and implement. All of our measurements come from the SI units. I'm not talking about weight, although it is important if a client asks us to install heavy equipment on the top floor of a flat that has no lift. I'm talking about things like power, current, resistance and voltage. We use our handy triangle to fill in the missing value. What really tripped me up this week is what I have in my upcoming exam: parallel and series resistors. Series resistors are easy. You combine the total of all the resistors, whether it be a physical resistor or devices, and then you got your total. But parallel involves finding a common denominator, then dividing all the resistances to give a fraction, which we can then add together to turn into an ohm value. In our resistor example, even a wire is a resistor and it has a value. All of this is in our handy little book, BS 7671. Resistance of a wire is also affected by its length, cross-sectional area, its resistivity. Gold, well, that has far less resistivity than steel for an electrical current. Finally, temperature affects resistance. The hotter a conductor, the higher the resistance. The opposite of a conductor is an insulator. A good example of an insulator is those that are connected to our power lines, that connect them to their supporting towers. The higher the voltage, the bigger the insulator. I looked at so much more this week, such as efficiency, measuring the work or power out compared to the input energy or power, along with all its calculations, which I'm just not going to bore you with, okay? All of what I studied this week felt a little bit like school days, and science was my favourite subject at school. More specifically, physics. I plan on using this channel to help to share how people are using science and processes to achieve all sorts of goals. Getting back to electricity, I touched on the effects of an electric current being magnetic, thermal and chemical. I could spend all day talking about these. Just looking at some of the processes in the energy transition to highlight these. Energy is being stored as heat in sand batteries to allow later use by converting to steam and turning a generator. Batteries are storing chemical energy from wind turbines, which are turning a generator to produce the electrical current. I looked at how we measure voltage, current and resistance to give us our power measurements. I also touched on magnetism, the conversion of energy into magnetism, which can then be used in motors to power our world, or transformers to convert the voltage to either a higher or a lower voltage. You can even pick things up with magnetism. Oh God. There was so much to consider this week, and I did enjoy studying it. The rest of the book was material that I've talked about on this channel before. This has me finished my 5th book, whatever will next week bring. If any of this video's information or any of the other videos you found useful or entertaining in any way, please just like and subscribe. This is an entire journey on how to become an electrician from start to finish, along with all the other stuff that I want to share too. I want this place to be a place of learning and an oasis from day-to-day life. See you next week. Battery Man out.